All right, so I think this is recording. Let's take a look here at problem number 2. We have a polynomial function, and we have several things to answer about the graph of this polynomial function. To select the correct end behavior, the end behavior is what's happening in the graph when you're very far away from the origin, far in a positive sense and far in a negative sense. In other words, as x approaches positive infinity or as x approaches negative infinity, what is the graph doing? And it's always one of 4 possibilities for a polynomial function. So to determine which possibility to pick, we have to identify the degree of this polynomial. When it's in standard form, the degree is the largest exponent on our variable. Let's check and see if this is in standard form. Are the exponents in descending order? And it looks like they are: 7, 6, 5, 4, 3, 2, 1, and a constant. The degree is the largest exponent, which is 7. And we want to identify 7 as an odd number. Now the leading coefficient is the coefficient for that term that we just used to determine the degree. So it's this leading term, and the leading coefficient is 16. And 16 is a positive number. So the end behavior then, since the leading coefficient is positive, it's going up to the right. And since the degree is odd, the end behavior is going in opposite directions. So as the signs on infinity won't be the same, they'll be opposite in sign. And it's, as you move to the right, it's going up. As you move to the left, it's going down. So it has to be case 3 right there. All right. The y-intercept, if you evaluate this function at 0, if x is 0, all of these terms are 0 until you get to this constant term, which is 81. So that's on the y-axis. Since it's positive, you've gone up. So the coordinate of that point, since you're on the y-axis, you haven't moved left or right, is 0, 81. That's why we let x equal 0. We plugged in 0, and of course in an ordered pair, this is x and that's y. All right, so now we want to look at this in factored form so that we can identify the zeros of this polynomial function. That's the x-intercepts. So we want to solve this equation. 0 is equal to 16x to the 7th minus 120x to the 6th plus 213x to the 5th plus 229x to the 4th minus 606x to the 3rd minus 270x squared and plus 297x plus 81. So we really don't have any kind of a method, any kind of a way to factor a large polynomial like this. So we've gotten some help here in this table. They're telling us that x equals 3 is a 0 of this function, that 3 is a solution to this equation. In fact, it's with a repeated, with the multiplicity of 3, it has a repeated root. So we can do synthetic division 3 times on this. So that's what we're going to do. And each time we're expecting to get a remainder of 0. So let's make sure we don't have any missing terms. I don't believe that we do. When I wrote it out, I don't remember any missing terms. Right. So we're expecting a 0 right here. Let's see if we get it. Let's pull the 16 down. Multiply. So I don't make a mistake, I'm going to pull up my calculator. Well, I thought I was going to pull it up. There we go. Negative 72. Negative 216. $54. Yeah, let's see if make sure that I don't make a mistake. Yeah. Yeah, so everything is good there. All right, so let's do synthetic division again. And again, we should get a 0 right here. Let's double check that. Oh. This calculator's kind of nice. And we get another 0. So we can do it one more time. And again, we need to get a 0 there. And we do. All right, so what does this do for us? Well, we're done with the x equals 3, and 7 minus 3 is 4. This is still 16x to the 4th, 24x cubed, squared x. So still this is something we can't factor, but if we return to the table, we have -1 with a multiplicity of 2. So we can come in and do synthetic division on this with -1 now, and we can do it twice, and we should get a 0 each time when we do it. Let's shrink this up so that I can have some room. All right. See what we get here. And it looks like we do get a 0. And we can do it one more time. And again, we should get a 0 right here. Let's see if we do. And it looks like we do. Okay, so let's come over here and see what we've got. So we were solving this equation, and this synthetic division has allowed us now to factor this to x minus 3 to the 3rd power. That's that multiplicity of 3, and remember that you change in factored form, you change the sign. And this one right here now is a quadratic. So we have the x method. We're able to factor this. So I'm going to erase this over here so that I have room to work. All right. So let's place an x over here. The middle term is at the bottom of our x, and the first term times the last term is up at the top of our x. So two numbers when multiplied together give us -48, but add together to get -8. So let's look at the prime factorization. Let's break down 48. And then we'll build it back up. And so we've got 4 factors of 2, which is 16 times 3. And if we group this together and get 4, and group this together and get 12, and the difference between 4 and 12 is 8, so we've got it. So if we make this a -12x and this a 4x, I should have seen that faster. It's just kind of early in the morning. I didn't sleep that well last night. With the leading coefficient different than 1, we want to chart it. So along one diagonal, we put our first term and our last term. And along the other diagonal, what we found in the x. So we look across here and we don't have any common factors, but here we have a -3. 4 divides both of those and they both have an x. And then 4x is common here as well. So that allows us to come in and to finally complete this, and we have this now in factored form. So this, when they ask for it in factored form, this is our function in factored form. They called it p of x. And so now in factored form, we see that 4x plus 1 in 2 steps, by subtracting 1 and dividing by 4, we get another 0. And here, by adding 3 and then dividing by 4, we get another. Both of those have a multiplicity of 1. And so now if we come through here, anytime the multiplicity is odd, it's going to cross over the x-axis. That's how it intersects the x-axis, is by crossing it. But when you have an even multiplicity, it touches it. It doesn't cross over it. It has a touch and turn. All right, so now on the original paper there, they have a multiple choice for us to identify the graph. So let's come back up here to our end behavior and then use this table to make a sketch to kind of know what to expect. So I'm going to erase this stuff because we don't need it anymore. All right. So let's sketch our graph over here. So our y-intercept is way up here at 81. We have 2 negative x-intercepts and 2 positive x-intercepts. And the smallest one is the -1, and it's doing a touch. So this end behavior, since this is doing a touch at -1, it's going to come up and touch it and turn. And then here at -1/4, it's crossing over it. So at some point, it's going to turn. Now I don't know how steep or how far down it goes before it turns and comes up and crosses over. And then somehow it's going to approach this y-intercept. Whether it actually goes above and then comes down and cuts through it, we don't really know. So I don't know how it's going to intersect that y-axis other than it's going to cross over it. Now it's going to head towards our positive x-intercepts, which was 3/4, and at 3/4 it's going to cross it. So this is 3/4, and this is going to cross it. Now, again, I don't know how steep or how far it's going to go down or how exactly it's going to turn, and then it's going to come up towards this x-intercept of 3, and it's going to cross it as well. And then it's going to go up. So we had 4 x-intercepts, but only one of them was a touch, and that's here at -1. So everything, this is kind of the sketch that we're looking for among our choices. So we're going to probably be able to eliminate some of them simply based on the end behavior. And then we're going to look for that one that's a touch, and the other ones have to be crosses when we look at this. So let's look at, see if I have this. Yeah, there we go. All right, so it's going up to the right, which rules out number 3. So it's either 1, 2, or 4 just based on that. Now, on the, it can't be, yeah, it can't be, I'm sorry, let's see, up to the right is 2 and 4. So I can rule out 1 and 3. All right, now between 2 and 4, here at 2, it is doing a touch, and there's a cross, a cross, and a cross. So 2 is looking pretty good. And yet, so is number 4. So do I have, I kind of have, it looks like the same graph chosen twice here. I don't see a true significant difference in those. So I've accidentally cut and pasted the same graph more than once here. Do you see how the graph of Roman numeral 2 and the graph of Roman numeral 4, I can't really see a difference. So we'll just, I'll try to correct that on your paper. So here, I'll delete this one and we'll call it 2. All right, so hey, I hope that helps, and I'll talk to you later. Bye.